sit right back and you'll hear a tale of a mighty sailing man. He worked too hard as the day went on and his temperature rose too high. The man set sail for a 1-hour class aboard a tiny ship. He left that day from a tropic port, but something went amiss. The weather started getting hot and his temperature rose too high. To save himself, he jumped in the water in the hope his temperature would drop. In this problem, we will calculate how long it takes for the body to return to around normal body temperature at 37.5 degrees Celsius from a state of hyperthermia at 40.5 degrees Celsius while immersed in the ocean with a temperature of 10 degrees Celsius. We will calculate how long it takes for the temperature of the water to cool the person back down to normal body temperature using Newton's law of cooling. We began with the accounting equation for the conservation of energy. Since there is no energy coming in or out, these terms are zero. There is no work being done on the system, so the work term is also zero. This leaves us with the heat equal to the mass times the specific heat and the difference in temperature. We assume that the mass is constant through the problem, so it was removed. We start with Newton's law of cooling and then integrated to find the final equation to use for this problem. The temperature of the man on the boat is 40.5 degrees Celsius, and the temperature of the ocean, the ambient temperature, is 10 degrees Celsius. These numbers were plugged back into the previously found equation to create the final equation. From a study on the drop in temperature while in water that is 10 degrees Celsius, we retrieved the information that it takes 35 minutes for the body to reach 35 degrees Celsius. We then plugged these values into the above equation to find the constant to be a value of 0.0057. To find the amount of time it will take for the body to drop from 40.5 degrees Celsius to 37.5 degrees Celsius, or around body temperature, we plugged 37.5 in for the final temperature and the newly found constant K. We plugged all of this into the equation and we calculated that it would take 18.165 minutes for the body temperature to drop from 40.5 degrees Celsius to 37.5 degrees Celsius. Oh no! There is a shark 1,250 meters away and swimming towards the sailing man in the ocean. The shark swims 950 meters and then accelerates to a top hunt speed. The shark still needs to travel 300 meters to reach the man. Will the sailing man survive?
Whiteboards, 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 whiteboards.
Will the man escape getting a whiteboard? Unlikely. Boatway sharks have a cruising speed of 2 miles per hour and a top speed of 25 miles per hour, which they accelerate to at 1.5 meters per second squared. The shark starts 1,250 meters away and notices its prey at 300 meters away. Using kinematic equations, we can determine if the man will cool in time to escape the shark. For ease of calculations, we convert miles per hour to meters per second. Since the shark will notice the man 300 meters away, we can calculate how long it takes the shark to cruise to 950 meters. Rearranging v equals d over t, we find that it takes the shark 1,062.64 seconds for the Boatway shark to travel 950 meters. The shark notices the man and begins accelerating. Rearranging vf equals vi plus at, we can determine that it takes the shark 6.855 seconds to reach its top speed, 11.16 meters per second. We also need to determine how far the shark travels in those 6.855 seconds using d equals vit plus 1/2 at squared. This gives us that the shark traveled 41.37 meters. At this point, the shark has taken 1,069.49 seconds. To find how long the shark takes to travel the remaining distance, which was found to be 258.63 meters, we again rearrange v equals d over t. It takes the shark 23.14 seconds to complete the remaining distance. Altogether, it took the shark 1,092.63 seconds to complete the 1,250 meter distance. The man takes 18.165 minutes to cool down, or 1,089.9 seconds, which means the shark misses him by 2.73 seconds. I guess the man doesn't get a whiteboard after all. No more hyperthermia for the mighty sailing man. No more Boatway sharks who escaped for today. But the whiteboards will return again to make him think in class. He's in class for a long, long time. He'll have to use the whiteboards